Hi everybody, we are Marco, Eleonora and Enrico from Politecnico di Milano and NECSTwork. We are working on a project called NECSTwork that will be presented to the Xilinx Open Alpha Contest 2016. In this new presentation, we will talk about our implementation. These are the main steps for our work. Firstly, we receive images from functional magnetic resonance imaging, and then we will go through image processing in order to obtain images with specific colored areas and a clear graphic reconstruction. Image acquisition can be done by functional magnetic resonance imaging machines. There is a strong correlation between brain cells metabolism and the blood circulation in the brain. In fact, more active areas of the brain need more oxygen in order to properly work. And this is why these areas receive more oxygenated blood. A blood oxygen level dependent signal can be acquired, and it is possible to understand which areas of the brain were mainly activated. When we obtain the images we need, there is a pre-processing step, the linearization of the images. We used MATLAB to acquire images because it's both fast and useful for our needs. MATLAB automatically extracts the linearized matrix from the uploaded images. Once we've done this, images are ready to be analyzed. Our Angular implementation can be schematized in three main steps. We start from a C code implementation of our algorithm. Then we use it to synthesize an IP core we will use to create the design for our FPGA. Finally, the FPGA can be programmed using Vivado. We start from the C code implementation of the Pearson's correlation coefficient algorithm, PCC in short. Here's the coefficient formula. The R index represents the value of the Pearson's correlation. X and Y represent the selected pixels, while X bar and Y bar are the mean values. Then we use Vivado HLS in order to obtain a high-level code from the C code implementation. Then PCC IP core can be used for hardware implementation. In the end, the hardware design can be created, and the FPGA can be programmed using Vivado. Once PCC has been calculated, our idea is to create 2D images, where activated areas are colored. Correlation will be shown by colored areas of the brain. The idea is to create a C code, which will consider the average response to a stimulus. Activated areas will be highlighted, depending on a specific time threshold. This C code will be translated to OpenCL and will be run on GPU. But we're actually still working on this. The last step will be the reconstruction of the images. Our idea is to create a more user-friendly graphic reconstruction that could be understood also by people who are not experts. This is still a work in progress, but we're working hard. Feel free to send us an email if you have questions, and don't forget to follow us on Twitter and Facebook. Thanks for watching.